I'm here in Shenzhen, China, and I'm off to go see a really interesting new 3D printer. Big thanks to LightMake for sponsoring this video. Vic, good to see you.
Nice to meet you. Welcome to LightMake.
Thank you. I'm really excited to see the printer you guys are building. Okay, this is super cool. You've got 4 separate independent heads all working at the same time, printing 4 different objects, which is amazing. Where are the motors? There's no motors in here driving your x-axis, driving your y-axis. What's going on?
Our print used a new type of motor. It's a linear motor. Here is the motor. Yeah.
Oh!
No belt.
There's no stepper motor pulling the head back and forth. You guys have 4 heads moving at once.
Yeah, it's not contacted by belt. It's driven by magnet force. The lifetime is the upgrade 10 times to 50,000 hours.
That's super cool. This is my first time seeing linear motors. I want to better understand how those work, and I want to explain to people the difference between regular stepper motors and linear motors and why that's so interesting. Oh, awesome. So you have like a test running here on the bench.
This is our linear motor, work simple. The linear motor have grouped by 2 parts. The first part is the forcer. The second part is the stator. He can move on the magnet north and south, move and repeat it.
So these are like neodymium magnets. You have them oriented north-south
Yes.
here. And then you have basically 3 electromagnet coils. Those can be charged separately. That creates a magnetic force that then pulls this along. Yeah. These are spaced interestingly, right? So this is not the same spacing. The distance between these is not the same distance as between the magnets, right?
Yes.
So it can pull it evenly across. You can set any distance, not just increments of one magnet. Okay, let's compare this. This is a traditional stepper motor, right? This is in a circle, and this is an unrolled version. So you can see here, these are the same, right? This has the coils.
Yeah.
The coils are here, right? You can see one here, one here, one here. There's some underneath the circuit board. So this has many magnets to make it very precise, but it's the same thing. This is just an unrolled, bigger version of this. The coils are energized to pull the magnets around, and that allows you to turn the motor to very precise positions. So how do you know where the head is along here? How do you know the position?
We have a magnet sensor. He can read the sensors strong or north and south to divide the 4,000 areas.
Yeah, like 4,000 positions. You can make the position anywhere along here, right? You can set a very fine position using only 3 coils. Whereas the stepper motor has what? That probably has what, 8 maybe?
Yeah, it's 8.
Yeah. You have some prototypes in here. Let's go see those. I want to hear, why did you build this printer? Why use linear motors? What's the whole idea behind this? Let's go in there and see.
I'm a mechanical engineer background. I hope to truly design or develop some new specific 3D printer.
Got it. Okay. Yeah. And what problem did you want to solve?
In 2024, I have been with a bigger print farm. Here I have more than 1,000 printer. When I was a tourist in that factory, I found a lot of the waste filaments behind the 3D printer. Almost 200 3D printer wait to fix.
We're broken.
Yeah, the most of the problem is the belt. The belt needed to wear out and aging and fixed every 3 or 4 months.
Oh, wow, because they're running their printers 24 hours a day, 7 days a week, right?
Yes.
Yeah. So running them much more than a consumer would in their house.
I decided to develop a new 3D printer that was more stable and more low cost and more easy to use.
Got it. Specifically for print farms, for people who are printing a lot.
Yeah, this can print more fast. Yeah. The first time we designed this machines, it have 4 independently print head, but it have a big problem, the same as the belt.
This was your first prototype?
Yes.
Oh, okay. Got it.
It's very complex, the belt. Yeah, too much belt.
Yeah.
This is our first land motor test platform.
Got it.
Yeah, this is no belt. It's very long time and no maintenance, no fixed.
The only moving parts here really are your linear rail underneath, and then you don't really have anything touching in the motor. You have both this direction and this direction are linear motors.
Yeah.
It's a smart design. Very cool. So this was your first linear motor prototype.
Yes.
Why are these turned?
Because the linear motor have to move from the north magnet to the south magnet, have a little gap. Maybe we position between the two magnets, maybe stop a little time.
Oh, if you twist them, it helps pull it to the next one.
Yeah.
Give a little bit of overlap.
Yeah.
Yeah, okay. So this was 1, this was 2, then 3 down here. One thing I notice here is you have 4 print heads. You also have 4 print plates that are all separate.
Yes.
Which is the same here, right? 4 separate print beds that move up and down.
Yeah. This is the first generation of the printer header.
Yeah.
The problem is it can't move up and down. The printer bigger size of the motor.
Right. So you can only, like your max build volume
it's
is
very
this.
small.
Yeah, okay.
So now we upgrade this generation of printer and improve this printer header. And later we improve the auto move.
So the head moves up and down. Awesome. You can print basically 4 times as many small parts, right? This is essentially 4 printers in one for small things. And you can do 4 colors at the same time for one big print without having to switch filaments or anything. You just move the next head in. Yeah, that's very cool. And then the idea is that you can print for much longer without having to do any maintenance because there's so few moving parts that can break. I want to see how you build your linear motors.
The first process is assembling the split magnet to a line, to a small group of the line.
Putting them in a jig, north-south, gluing them onto the metal?
Yes. Okay. The second step is make the small line into a 1X.
So putting them in here now?
Yes.
Oh, I see, and they just slide right in?
Yeah. Yes.
Is this custom?
Yes.
Yeah, custom aluminum extrusion. Sweet. A lot of people don't know you can get a custom tool made so you can squirt out whatever profile of aluminum you want.
The next step is set up the ring.
Okay, yeah, the linear rail. So screwing the linear rail on.
Yeah.
Yep. Yeah. And so that's the only part that touches is this. We were talking about this earlier, but these are basically like a linear ball bearing. Rather than a round ball bearing, there are balls in here that ride on the rails. So it's a very smooth travel and very low wear.
The next step is coil winding.
That's cool.
Yeah.
Pretty automatic. And so this is the counter here for how many windings? It's like 165 there. This is very similar to the motor factory we saw where they were winding the stators. We'll put a link to that down below.
The next step is put the 3 coil in a 1 forcer.
Oh yeah, okay. Yeah, so you've got like an aluminum enclosure or something. So you put this inside.
Yes.
Oh, I see, yep, got it. So this is like your plate stack up in your stator and your motor. So steel, and you put the coils around this, and then that's kind of your exposed face of the electromagnet.
The next step is we'll set up a PCBA on the forcer.
Okay, you've got a circuit board, a PCB on top, and and I see, just soldering on the wires for each coil. So what's she doing?
This is the test that all forcer keep the performance is the same. Every linear motor will do the same test in the factory. Keep the accuracy and the precision is 1 micrometers.
You've got a fixture here. There's a micrometer here that's making sure when it comes down that it's coming back to exactly the same point. Well, let's go on and see the progression of assembling the full machine.
This is the first step of the machine's assembling is the base frame. The next step, we will set up the 4 pillow on the base frame.
Got it. And these look like they're, again, that custom aluminum extrusion. So you designed this shape?
Yes.
Yep. Yeah, and then I noticed these are 3D printed. Is that going to be the final version, or?
Yeah, the final version, we will use the ABS and the PC.
Okay. So it'll be like injection molded.
Yes.
Okay.
Yeah.
Okay. So just to stand in for now.
Yeah.
Yeah.
The next step, we will set up the hotbed. We will prepare the up frame. Next, we will set up the up frame on the whole machines. This is the supply books.
So
Power supply
power
books.
supply and
Yeah.
the driver circuit board.
Yes.
For driving all the various motors and whatnot.
At this step, we have to set up the whole frame.
Yeah, so the top part with the x-axis linear motor. Oh, and I see here then you've got your y-axis with their heads.
To here, this is the PCBA of the linear motor. It controls the linear motor.
So like the linear motor driver
Yes.
circuit board. Yep.
We will connect all of the cable and the machines and connect all of the linear motor cable. This is the print header.
So you've got that linear slide that we were talking about earlier, that linear rail that's real short. And then you've got a stepper motor here with just a really short little screw. Otherwise, that looks pretty similar to other print heads I've seen. I think you've got some like QA, QC testing over here.
Yes.
Okay, awesome. Let's go over there and take a look at that.
This is the linear motor test platform. It's run from the 2025 October until now. Today is 257 days.
Wow. So this is like making sure that they don't wear out, that they will last a really long time. Yeah. Awesome. What are you testing on this printer?
We will do the test, the coloring model test in every printer before offline.
Awesome. So like a 48-hour burn-in per printer, make sure there are no issues, and then send it out to the customer.
Yeah.
Awesome. It's worth noting this print is a multicolor, it's a 3-color print. And because you've got 4 print heads, you can have one dedicated to each color. So they can just come in and print their color and then move out of the way and another print head comes in. You do have a prime tower just to get it printing nicely before it comes in. You were saying it's a real speed up in print time?
This is our test print model. It can print this model only in 4 hours in our printer, but the other kind of any printer must print more than 20 hours.
Wow.
Can save 80% of the time.
Yeah. That's awesome. Yeah, so the 4 heads are a lot easier to switch between.
Yeah.
Awesome.
Yeah.
Fantastic. You guys are launching a Kickstarter.
Yeah.
If you would like to learn more about this printer and get one of your own, click on the link down in the description. Thank you so much for sponsoring this video and for showing what you're doing. This is super cool. Yeah.
Thank you.
We'll see you again soon.